Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade concept of the Pythagorean Theorem on a coordinate plane. This is standard 8.7D in the great state of Texas, and we are using item number 15 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got a line segment, LN, and we need to find its length. Now, we are tempted to just try to look at these units here and say maybe 1 and then 2 and then 3, but you notice that these units don't go through any of the coordinates, the whole numbers, right? So we can't really guesstimate here. So that's really not going to work. And that's not the way we're supposed to do it anyways. But even if sometimes you'll get something that goes exactly through this is not just one unit. Each of these are not just one unit. They're actually a little bit longer than one unit, and that's why we have to use something called the Pythagorean theorem. Now, all we have is a line. It is a diagonal line, but it is on the coordinate plane. So what we're going to do is we are going to turn it into a right triangle. So I'm going to extend a line from N all the way down to right below L. And let's just make this M. And I'm going to draw a line straight from L down to the new point I added, M. And you notice here, now we've got a right triangle. And this is the hypotenuse. And so that makes calculation something we can do now because the hypotenuse has a special relationship with the other two side lengths in a right triangle. So we had to provide those two extra sides. And so what we get here, let's see where it is on that reference materials. And it's going to be right down there at the very end. Additional information, Pythagorean theorem, a squared plus b squared equals c squared. Now you have to know what that means. But what this means is this is the a side, this is the b side. The two legs of a hypotenuse, the two sides coming off of the right angle, are the a and the b. Doesn't matter which one is which. The hypotenuse, that's c. So that means if you were to take a square with side length b and a square with side length a, add them together, you would get always a square with a side length c. That's just what the theorem tells us. Now, we don't actually have to draw the squares because that wouldn't really be super helpful. But what we can do is we can just substitute values in for a. So a runs from -1 up to 5. So 1, 2, 3, 4, 5, 6. So a equals 6. We'll just say 6 units. B runs from -2 up to 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Since those are straight lines, we can calculate that. All right, so what we're going to get here is we need to figure out what c is. Well, a squared plus b squared equals c squared. So let's substitute our values. 6 squared plus 9 squared equals c squared. Well, that's going to be 36. That's going to be 81. And that's c squared. Okay, so now we are going to be what is that? 117 equals c squared. Now, there's two ways we can do it. We could kind of estimate this because it says which measurement is closest to the length of line segment. So we don't need the exact measurement, right? So we just need to take the square root of both. Well, let's just find some square roots that are around that. So if I had square root of 100, that's going to be 10. I'm looking for my square root of 117, but I know that if I double 11, I'm going to get 121. You notice how that's very close to 121? So I'm going to guess maybe 10.8-ish. And so that's really close to 11. So I'm really thinking it's this 11. Now we have the calculator. So we don't need to do all that, but we could do it without the calculator if we wanted to. I just needed to show you that. So let's try 117. Let's do the square root of 117. All right, so we're going to hit our second button, and then that x squared to get the square root, 117. And there we go, 10.816. That does round up to our 11. So our estimation would have worked just as well. We will say that our uh, line segment LN is closest to 11, about 10.81 units. So the answer is D.